Today we will learn Maxwell's inductance bridge. Using this bridge we can measure unknown inductance. This bridge is a very simple bridge where we can see in the first arm we can see one resistance R1 and inductance L1. This resistance actually representing the internal resistance of this inductor L1. This is R2. This is L2 inductance, and small R2 is the internal resistance of this inductor. This is R3. This is R4. So here L1 is the unknown inductance. R1 is the resistance, that is the internal resistance of L1. So we know that when the bridge is balanced, that time the product of opposite arm impedances are equal. This one is a AC bridge, so alternating supply E is connected to the bridge between the point A and C, and the Z1, the impedance of arm 1 is equal to R1 plus J omega L1. Z2 is equal to R2 plus small r2 plus J omega L2. Now R3, R4, these are non-inductive resistance. So Z1, Z at balance, we can write Z1, Z4 is equal to Z2, Z3. So what is Z1? R1 plus J omega L1 at balance, the product of opposite arm impedances will be equal. So at balance we can write Z1, Z4 is equal to Z2, Z3. So what is Z1? Z1 is equal to R1 plus J omega L1, Z4 is equal to R4, and Z2 is equal to capital R2 plus small r2 plus J omega L2. This is my Z2, and Z3 is equal to R3. So from this equations, balance equation, what we can do? We can equate the real part and imaginary part. So equating real part and imaginary part, we have R1, R4. R1, R4 is equal to R2 plus R2 into R3 is equal to R2 plus small r2 into R3. So our objective, you have to find out the value of capital R1. So R1 is equal to R3 by R4 and within bracket capital R2 plus small r2. So this is one equations. Another equations is the imaginary parts. J omega is cancelled. We have L1 R4 is equal to L2 R3. So L1 R4 is equal to L2 R3. So what is L1? L1 is equal to R3 by R4 into L2. So this is equation 2. Using these two equations, we can find out the value of unknown inductance and unknown resistance. Now I will draw the phasor diagram, which is very important. So how to draw the phasor diagram? We have to draw the reference line, that is the current I1, I2 in the same line. The drop in this arm is I1 R1. So this current is I1, this current is I2. So this drop is I1 R1. So this is my I1 R1. Then inductive drop is I1 omega L1. So this is I1 omega L1. At balance, remember that this potential is say E1, this potential is E2, potential between A and D, and this potential is my E3, this potential is my E4. E1 plus E3 must be equal to E, and E1 must be equal to E2. So at balance, it is true E1 is equal to E2 and E3 is equal to E4, and E1 plus E3 is equal to E. Similarly, E2 plus E4 is equal to E. So in the phasor diagram, we must get it. So this one is the my I1 R1 plus I1 omega L1. The phasor sum of this is equal to my E1. So this E1 must be equal to E2. That means I1 R1 must be equal to I2 into R2 plus small r2, and this must be equal to I2 omega L2. Now I1 R3. This is my the same current will flow when the bridge is balanced. So I1 R3 is equal to E3, and this must be equal to E4. This is equal to I2 R4. We project this one, and this is my E3. This is my E3 plus E1, that is, this is E1 is equal to my E. So if we connect this one, we'll get E. Similarly, E4 plus E2. So this is my E4, and this one is the E2. E4 plus E2 is equal to E. So basically, first we will draw the current I1, I2 in the same line. Then this is my I1, R1. It must be equal to I2 into capital R2 plus small r2, the resistive drop. After that, the inductive drop, I1 omega L1, it must be equal to I2 omega L2, and this will be my E1 is equal to E2, and this one is I1 R3, that means this is E3 is equal to I2 R4, that is E4. So E1 plus E3 is equal to E. So this is E. Similarly, E2 plus E4 is equal to E. So this is the Phasor diagram. Thank you for watching.